Hey guys, today we're going to talk about factoring trinomials with an a value greater than 1. In other words, trinomials that look kind of like this. Of course, that a value we're referring to being the coefficient in front of the x squared. Now, the great thing about factoring trinomials like this is there's actually multiple different ways you can go about it. We have an AC method that we're going to talk about in another video. There's a guess and check method that you might be comfortable with, and there's something that is called the box method. Now, we're going to talk about several of these, but I'm going to make a different video for each one. And the important thing to know is that each of these will work. It's just whichever one you're most comfortable with is the one that you might want to start using. Now, in this video, we're going to talk about the box method. The box method is kind of like one of those tricks in mathematics, right? It's one of those things that it seems weird and it seems almost like this kind of unusual pattern of things that we're going to do, but it will work every time. So it's something that I found a lot of success in, but it is something you just kind of got to remember the steps. And because the steps are kind of odd, I have them written right over here. Let's go ahead and start this and just keep an open mind, because like I said, it is pretty weird. The very first step is to draw a 4-square box. And what I mean by a 4-square box is like this. Looks kind of like a window, right? Now, in each of these squares, we're going to put something. And you'll notice our second step over here tells us what we're going to do first. In the top left-hand box, we are going to put ax squared. And I've actually underlined every time I talk about one of these variables just so that we can make sure we see what that is and what I'm referring to. Ax squared is this first part of our polynomial, right? If you're unsure about the ax squared, bx, that kind of stuff, check out my video on standard form of polynomials. But we're going to put 12x squared in this first box. It then says in the bottom right box, put c. So c is our last term here, -5. We got to make sure we keep that sign with it. Okay, so we put ax squared and c in our top left box and our bottom right box. Step 2 done. Step 3 asks us to multiply a times c. Again, a being our coefficient in the first term here, c being our constant. 12 times -5, that gets me -60. Okay, so I'm going to write that off to the side. That doesn't go in a box. This is going to be some calculations I kind of just do over here. So I finished step 3. I multiplied a times c. 12 times -5 got me -60. Now, this is kind of the step we got to do a little thinking about. Find factors of a times c, which we already did. We found a times c. But find factors of a times c that add to equal b. Okay, so this is the tough part. b in this equation is -17. And this is a times c. So I need to find factors of this that add to equal -17. Whew. Now we know factors mean numbers that multiply to become -60. And then those two numbers need to add to make -17. This is going to require a little bit of thinking, a little bit of brainstorming. But long story short, I'm going to speed it up a little bit for the video here. Those factors would be -20 and 3. Now, it may take you a little longer to find some of these factors depending on the problem, but these factors will always exist. -20 times 3 makes -60. That's where we get the idea that they're factors, right? -20 plus 3 equals -17. That fits our criteria of step 4 here, that those factors add to equal b. So step 5 tells us to put these factors into the box. We have 2 open squares, and we can actually put them in whichever square we want. It doesn't matter. So I'm going to go ahead and write negative 20 in the box, and I'm going to write 3 in the box. But don't forget, the second part of step 5, it says write an x with them. So I'm going to go ahead and do that. So negative 20x and 3x. The final step to getting our binomials is this right here, step 6. We're going to find the greatest common factor of each row and each column. And what we're going to do is we're actually going to write those numbers, or those greatest common factors, out to the side of the rows and top of the columns. That way we can visualize them, see them, and that's going to help us get to our final answer, our final 2 binomial factors. So let's see how this works. When I look at my first column, 12x squared and 3x, what is the greatest common factor among those numbers? Well, between the whole numbers, 12 and 3, the greatest common factor is 3. I apologize for the bell there, so sorry. Then we have variables here too though, x squared and x. Both of them have at minimum an x, so they also have a common factor of x. When we take a look at that second column, we want to do this again. Negative 20x and negative 5. Well, in this case, they don't both share a variable, so there's going to be no variable common factor, but there may be a whole number common factor. Yeah, negative 5. We want to be sure, as it mentions here in step 6, you include the sign that you're able to factor out. If they are both negative, you factor out a negative sign with them because they have that in common. So this 3x minus 5 is going to be one of our binomial factors of this trinomial. Let's go ahead and look at our rows here. 12x squared and negative 20x. Well, 12 and 20 have a common factor of 4. They each have at least one x, so there's a common factor of x. Is there a negative in common? Do we need to take out a negative sign? No, we don't, because they're not both negative. For us to take out that negative sign, they both need to be negative. Let's take a look at our second one here. 3x and negative 5. Those don't seem like they have anything in common, right? Well, all numbers have at least something in common. What is that something? 1. Everything's divisible by 1. So even if there is no other similarity in their factors, we can say 1. And in this case, is it a positive or a negative 1? It's positive. For these quote-unquote second numbers, the second row, the second column, I always take out the signs, or I make sure I write the signs with them, because those signs are going to be part of our binomials. So ultimately, what this greatest common factoring tells us is my binomial factors are 3x minus 5 and 4x plus 1. And that's it. If I wanted to go ahead and FOIL these, I can double check, make sure I get back to my original answer. 3x times 4x is 12x squared. 3x times 1 is 3x. Negative 5 times 4x is 20x, negative 20x. And negative 5 times 1 is negative 5. These combine to be 12x squared minus 17x minus 5. Right where I started. And that's the box method. Again, I know this is kind of a weird way to do this, and really unusual, probably nothing like you've ever done in math before, but it's effective. So if this is a method that works for you, if you can remember these 6 steps and how to do it, and I promise once you do it several times, it becomes kind of second nature, you're able to do it real fast, then this is a really, really good way to factor, in my own personal opinion. Do be aware, if I didn't already say this, that you need to make sure there is not a greatest common factor among your trinomial at the beginning. Before you start the box method, you need to make sure there is not a common factor amongst the trinomial to start with. The box method will not quite work so well if you haven't already taken out any greatest common factor here. Again, I apologize for the bell. I was hoping I'd get the video done before that happened. I'm going to have a second video that goes over 2 more examples of this, just so that we can all get a little bit more practice. If you want to keep an eye out for that, it'll be posted to my channel here soon. Thanks for watching, guys. If you have any questions, feel free to drop them below. See you next time.